I'll turn it over to Mr. Tony Abate. Good morning. How's it going?
Thank you, Tony. It's going great. Appreciate the time. And Tony and I were kidding. We were just going to call this Two Guys Talking 241.
That's right.
Maybe Netflix would pick it up or something of that nature. But anyway, first off, behind me, I'm not that smart. Those aren't degrees. Those are patents that the AtmosAir has amassed through time. So I just wanted to clear that up. What I wanted to do is maybe go into a little bit of what led up to this standard being developed, because it's an interesting story, and it kind of almost sets the stage for what happened from there. This is going back into like the fall of 2022. The White House comes to ASHRAE anticipating the end of Title 42, which expired in May of this year, which was the end of the public health emergency. So what they wanted ASHRAE to do was to come up with a standard for how to operate a building in preparation for an event similar to what we experienced with COVID. Not necessarily a pandemic, but an endemic event. So imagine flu season or other things that could, spread airborne illness in kind of a dramatic way. So ASHRAE then quickly assembled a committee. They picked Bill Bahnfleth, who, if anyone knows, is a past president of ASHRAE. He's the chair of the Environmental Health Committee, been instrumental in a life member in ASHRAE, and done many, many things with ASHRAE in just his volunteer life. So they, tabbed Bill to chair this committee, and then Bill to go out and select the members of the committee. And it wasn't like a typical ASHRAE committee where basically, let's say it's 62-1, and you'd like to be a part of it. So you kind of go on the website and you put in your information, you have your bio and your application all filled out, and you're basically on the committee as a provisional corresponding member. And then, of course, depending on your participation, you may roll up into more of a permanent role, a voting member and such. But this was by an invitation. So Bill went out there and picked this committee. Very vast, varied people from all different types of expertise, built environment, members of research and academia, people who were involved in like the study of infectious aerosols and communicable disease and all sorts of different things related to how to put this standard together. I'm glad I was asked to participate in the committee. So the committee was assembled in December. And then by February, we had our first official meeting. So I'm only illustrating that because by June, we had a voted on standard. Now, for folks there who've been involved in ASHRAE or know about ASHRAE, if you get a standard done in a couple of years, you did really well. Mm-hmm. This is like essentially 4 months of work to develop this. So this was like, this was telling Scotty, I need way more power, not just more power, beyond warp speed. Mm. So we went to work, and I got to say, I've been involved in ASHRAE for, 15 years now actively, serve on a lot of different committees, chair a couple myself. And I've never had so many committee meetings in such a compressed time as I had with this particular group. We were meeting as a full committee every 2 weeks. But then if again, on an ASHRAE committee, things get split up into working groups and different other groups that really kind of do the work needed to build things. So in the working groups and even drilling down into sub-working groups, there were meetings happening several times a week when you rolled it all up. So, I mean, in 4 months, I had as many meetings as I had in 4 years in the normal course of business with ASHRAE. So, extremely expedited as far as this was concerned.
You get your ASHRAE overtime paycheck?
Well, I got the shirt, so I mean, but anyway, and I got a pin. Believe it or not, they gave us all a pin that looks like the Roadrunner because we're so swift. And so,
right.
My daughter was making fun of me because of that, but that's a whole different story. Anyway, so the goal was, how do we develop guidance into what spaces should do? When I say spaces, this is not limited to buildings. It's spaces of all sort, commercial and residential. What is guidance that could be given during a heightened risk? And then developed from that was a thing called infectious risk mitigation mode. So, okay, there is a reason to be concerned about the spread of an infectious aerosol. What are the things we must do in our space to protect against people being impacted by that? So we went to work looking at how to do this. And again, because of the haste and the speed needed to get there, the first thought was, let's not try to recreate the wheel entirely. So let's take standard 62.1, 62.2, and standard 170 for healthcare, and almost use those as the baseline. And then let's build upon these enhanced measures that would, again, protect people from being impacted by pathogens.
So is this more of a reactionary design guide? If there's a emergency, do this, or is it like, if you want to prepare your buildings for emergencies, start with this?
Well, yeah, yes to both in a way, Tony.
Okay.
Yes, it's absolutely a guideline to say, if there's an enhanced risk, affect or take measures to reach these newly targeted CFMs per person that are all spelled out in a table in the standard. So when you look at it, just to give an example, in office, it says to bring in 30 CFM of equivalent clean air, and I'm going to explain that aspect, very different from what's typical at ASHRAE, as opposed to what's right now in a 62.1 standard, which I think is 5 CFM. So it's significantly more ventilation.
Yeah, for sure.
So, and again, if you go through the tables, they look at every, like a 62, but imagine 62 and a 170 and a 62.2 being melded together. All different environments. So it could be an office, it could be a gym, it could be a patient room in a hospital, it could be a sports facility, whatever the case might be. And all of these CFMs are laid out. So there you have what you need to achieve, what you need to get to in order to comply with this standard and say you've provided as much pathogen-free air as possible to keep occupants safe. Now, how do you get there? And that's the big, really the big, I think, change in this versus many other standards that ASHRAE's published before.
So this is right here, Tony, 5.1.
That's your table 5.1. And yeah, exactly. Those are all those enhanced CFM per person. And just look at them. For instance, a gym, 80 CFM of air per person. You know what the occupancy of a gym would be. So that is a lot of air. So how do you get there? Well, for one thing, you can design in your mechanical system to have the capability to bring in that much outside air. Very likely it doesn't have that. It likely was never designed for this.
Right.
But you could redesign it. you could take whatever steps are needed and you can achieve these rates. It's not impossible. Probably impractical, but not impossible.
Right.
And again, this isn't meant to be continuous. It's meant to be during the heightened concern.
Right. Emergency mode. Right.
Exactly. Okay. Now here's where something very interesting comes in that was really, again, I think kind of groundbreaking. The concept of equivalent clean air for infection, ECA with a little I. And what that means is that rather than just simply relying on outside air, you could look at air cleaning. The whole point is to deliver pathogen-free air. Now, if you bring in a lot of air from the outside, chances are it's going to be pathogen-free. And if it isn't, we have such bigger problems, it doesn't really matter what we did in the building. However, there are lots of ways you can provide pathogen-free air in a building. You can take different types of air cleaning strategies, either singular or layered, and you can, again, deliver pathogen-free air to the occupants. So what the standard says is, well, I don't really care if you use air cleaning to deliver pathogen-free air or you use outdoor air to deliver pathogen-free air. Just be sure you deliver 80 CFM per person of it in a gym, for instance, and so on and so forth. So very different from all other ASHRAE standards, which basically always rely on the principle of dilution. Bring in a certain amount of outside air, and then you will produce acceptable air quality.
Right.
It's really the oldest indoor air quality adage that's ever been used. Dilution is the solution of pollution. 62.1, ventilation for acceptable air quality, but just built on that premise. I mean, if you go with VRF method, you know, what is it really doing? You bring in a certain amount of outside air per person, and the building is assumed to be good. So here, air cleaning becomes now a very viable part of the strategy. Because again, as you look at those tables and look at those rates that you must achieve, it's really very unlikely you're going to do it with outside air, again, unless you take in some major redesign and major cost implications, not just to be able to have that airflow available.
Right.
But now, of course, you want to make that air comfortable, so you have to condition it all. So
I'd say the chance of that happening is pretty close to zero ever.
Well, yeah, I was talking to one of our engineers that I work with just earlier today, and really think about the engineer that has to design a space.
Oh, it's crazy, right?
So, is he going to design, 80 CFM per person times the occupancy, thousands of CFM of outside air, which again isn't going to be used on a continual basis. It's going to be used when it's needed.
But you still have to design your system for that peak.
Exactly.
If it ever happens, if you got a gym that's normally 40 tons, now you've tripled that. I mean, yeah.
Right.
It's great.
So you have this V8 engine that you're going to be running on 4 cylinders most of the time. Right. So it's again, much less likely that you're going to do that, but much more likely that you're going to look at air cleaning.
Right.
So in a sense, from the AtmosAir perspective, as this was being developed, I was pretty excited because I said, now I think air cleaning is finally getting its place in an ASHRAE standard in a more prominent way and not kind of hidden in the shadows of like the IA2 procedure, so to speak. Because here, being able to clean that air is equivalent to being able to use outside air, equivalent clean air, all about delivering pathogen-free air. Now, how you do that is defined in different parts of the standard. They talk about categories of air cleaning systems, What are the types of air cleaning systems? These could be in duct systems. These could be in room systems. This could be a combination of both. So there's really an agnostic approach to air cleaning as far as the standard is concerned. You don't need or aren't limited to one type of design or another. It just depends upon the effectiveness of your technology, and how it can then, by means of calculations that are put into the standard, contribute to that ECAI number that you need to achieve.
Does it go into the specifics of the types of technology, or just says you've got to meet this equation based on some testing data that you already have, or how does that look?
Yeah, it doesn't really specify types of technologies, but it really specifies what those technologies have to achieve as far as proven effectiveness and also proven safety. At the end of the standard, there's a section called Normative Appendix A. And really, Normative Appendix A, that kind of lays out what constitutes the effectiveness of the air cleaning system. So what types of testing should it have? What kind of performance metrics should it have? What kind of safety metrics does it need to meet? Very well spelled out, very well defined. And what you'll kind of see is that it's kind of depending upon manufacturers that have tested their product to standardize test methods. So a lot of manufacturers have a lot of products and claim a lot of great efficiencies, 99.99999 to do this, that, the other thing. It's not uncommon. But when you kind of peel that onion back a layer, you may find that they achieved that in a customized test. So the manufacturer went to the laboratory and said, I would like you to test this product this way. The laboratory says, you're going to pay me to do it? And they say, yep. And so they do it. So what this is saying, and really what I think, more premier manufacturers will do anyway, is they'll test the product to a standard that already exists. So they say to the laboratory, test my product, and what protocol, what test method would you apply to this product? So, for instance, let's say you're testing a portable room air cleaner. And you want to show how well it removes particulate. Well, there's a standard for that. ANSI AHAM AC1. That's, you see right there in 241. Hey, if you have a product and you've tested to that standard and you have a performance measure to that, well, that's great for us. And you could put it right in here.
So these are the standards you're referring to right here.
Those are some of the standards.
Some of the standards, gotcha.
Yep. There are others. This doesn't limit to just this group to say, unless you're tested to these performance metrics, you can't use the product. Again, if you keep scrolling down a little bit, Tony, where the effectiveness or safety, American system is not covered by any of the above standards. It gives you the opportunity to really use something that has a national consensus standard. Did
I pass it? Am I almost there?
No, you actually went too far.
I went too far. That's what I thought. Yeah. Let's see here.
You go back a little bit more. Let's see, where are we? You're just right there. So that last paragraph.
Ah, gotcha.
Custom tests shall be performed by a third-party independent laboratory in accordance with the conditions in Normative Appendix A. So it's saying, hey, there's no, if your product doesn't fit one of these test methods, it's okay. Test it by an independent third party, but just they need to, operate within some of the criteria that are listed in the standard. As we go further down, it kind of talks about what those criteria are. Again, this is giving guidance to the laboratory. These are the things you should do when you're testing this product.
And for specific to AtmosAir, we already have that testing done that complies with this normative Appendix A?
Yeah, exactly.
Assuming,
But so
yeah.
Yeah, AtmosAir has done, first of all, one test that's called out very specifically above ANSI AM AC1. That's been done on the AtmosAir technology already. We actually did that many years ago and have a stated performance, which is in a metric called CADR, clean air delivery rate. You can take that and drop that right into the ECA calculations to add to your equivalent clean air rate. That already exists. But also, AtmosAir's testing that's been done in the laboratories, like with microchem, for instance, looking at microbial reduction, things that were done against coronavirus, MS2 bacteriophage, E. coli, staphylococcus. These are all done to ASTM standards. And those ASTM standards conform to all of the requirements that are put into this normative Appendix A. So yes, those could drop right in. And of course, some of those, for people unfamiliar, were very impressive results. 98, 99% effective on these various types of pathogenic elements. So leading to AtmosAir being able to help towards that equivalent clean air calculation. We actually have begun to build out our IAQP calculator, which we've had for many years. We call it Atmos IQ, with now a 241 section, so that the engineer doesn't have to sit there and try to figure all these things out and spend days and days to try to boil all these calculations down, no differently when you're trying to apply the IQ procedure.
Right.
But we want to put our effectiveness into the calculations that are provided here and give a tool. So now that design engineer could say, okay, I'm designing this system. I need to hit this ECA. If I use AtmosAir here, along with the filters I plan on speccing and the amount of outside air I plan on speccing, do I get to the CFM per person that I need? And so that I think is very valuable, because some of the early comments I really got from this when the standard hit was, this seems great. I want to use it. I have no idea how.
Right.
Now,
if someone watching right now has an engineer who says that to him, what do we say to him?
Well, right now what we'd say to him is we're going to provide our calculator and say, at least from our point of the world, we have something you can use to apply our technology towards that calculation. There is a calculator that was provided as a part of this. It's really buried kind of in the end of the standard. There's a web page, a web link, which can get you to a website, which kind of brings you to a calculator that actually explains how ECAI is achieved. It doesn't tell you what any particular technology might do. It just says this is how to calculate ECAI. So that's a free engineer. But again, we want to take it a step further at AtmosAir, saying, okay, if you are going to design to this, and you also would like to use our technology, let's give you a calculator that allows you to put in that. Actually, that's it. That's the ECA calculator. But again, we wanted to give something that would help be specific to AtmosAir, also be kind of simple. Is
that available now if someone has an opportunity, or
almost
behind the scenes, maybe?
We're kind of putting trying to get the finishing touches on it. Our in-house engineers are kind of, we want to make sure it's right, obviously, before we put it out. But it's coming soon, and I think it'll be a real handy tool as people are starting to want to apply this standard. This calculator here, while it's very good to kind of explain things and kind of show, is a little complex. As you can see, look at all those different possibilities that you have there. So we wanted to do something to say, let's get you to the same answer, but let's try to take the shorter road instead of the long road.
Good.
Also, some of the things that this standard touches on, very different from a lot of other ASHRAE standards, is it goes into operations and maintenance. Usually most ASHRAE standards end with design. Okay, if you designed this, you did it this way, the building should run fine, go with God, you're all set. We all well know that the minute that certificate of occupancy is turned over, things change in a building. So part of this standard is not the fact that you designed something one time. It's that you need to keep records and maintain what you designed to be operating in the same state as you originally intended. So there is a lot here that goes into just beyond day one. Operations and maintenance and making sure that you are keeping these systems correctly operating for, to be able to perform the task they were designed to.
Excellent. Well, it sounds like a lot different than the standards before this, that's for sure. In terms of the, attention to the filtration aspect of it or the air cleaning aspect of it.
Yeah, it is a big departure. I mean, I've been involved again in a lot of ASHRAE standards, and certainly 62.1 being the most prominent. And again, when you kind of peel back to the core, they all seem to be based around one thing, and that is outside air and then mechanical filtration, somewhat, fibrous filters, but really about volumes of outside air to ensure clean air on the inside. Approach is kind of hoping to achieve a good result. This is taking a different approach. If you're looking at air cleaning systems that have tested, measured effectiveness, we can't test or measure the effectiveness of outside air. Outside air changes every day. We all well saw, especially in areas of the Northeast, in early June, what can happen when the outside air decides to turn on you with all those Canadian wildfires. So outside air is not a set thing. It's a variable. It's going to change in quality from day to day. My air testing background, the one thing that would drive me batty when trying to do, let's say, a comparison air test, is I knew what was happening in the building. I knew what was happening in the mechanical system I was testing, but I had no idea what was getting delivered from the outside. But an air cleaning technology that has tested, measured performance, what kind of is a known thing. So there, I think, lies to, a more precision approach, or leads to a more precision approach, I should say, in how you're going about your ventilation design. So I think it was a real change in the way ASHRAE does things. I think it was a very welcome change, I believe. The other interesting aspect here is, this ECA with the tiny I, to me, opens up the universe to say, well, where's going to be ECA with a P for particulate, or ECAV for VOCs, or so on and so forth. I think it's going to kind of start to impact other standards, saying, well, you can use the outside air. It's always there for you. But, hey, we're going to give you some more choices. We realize that air cleaning technologies haven't just hit the scene. They're well established. They've been tested and proven over time. And if you want to use those to deliver clean air to the occupants, you should.
Yep. I like it. Have you seen, I know it's rather new, so probably not yet, but have states talked about adopting this in certain types of facilities, or have you seen like certain institutions, a big college saying, okay, all of our buildings are now going to comply to this, or what have you seen in the field?
Right now, it's kind of early, so
it's too early, I'm sure, but
have heard some pretty major engineering firms that, we have AtmosAir some personal relationships with that have kind of looked at this standard and understood it a bit and saying, we intend to design to this. And we have some groups that we're working with that now have knowledge of this that are saying, we intend to, be prepared to design to this. What I think could likely happen, and it's kind of happened early on with the USGBC, is, the GBC and the LEED standard was kind of put out there and kind of, muttered along a little bit. But then it got a big boost by federal buildings saying, you must design to a LEED silver. And all of a sudden, you had millions and millions and millions of square feet going LEED. And then, we live in a Me Too world. So then, buildings in the private sector started saying, well, we should have to design to this. And so, USGBC obviously became very prominent. I could see something similar happening here because the impetus for this came from the White House. So it might be a natural thing for government to say, in government facilities, we want them engineered to the standard 241. We want to be prepared. And then that kind of a directive, when you have, prominent square footage starting to be designed to the standard, leads to that kind of Me Too approach. And then you'll see lots of, especially big corporations with their ESG initiatives and other things. How could they not say we're going to provide a sort of healthy building? They can say, no, we're going to provide the healthiest building we can. And our guide to that has always been ASHRAE.
Yep.
So, and many buildings in the private sector are doing these things. They have their own standards that they've developed to try to provide as healthy building as possible. But now they can fall back on ASHRAE for, official, code compliant guidance.
Got it. Well, good. Well, that's a great, I think, enough information to get people going on it.